Hi, my name is Jacob, and in this video series I'll guide you through the process of creating your first URcap. In this video we will develop the program node view. For the sake of demonstration, we will create the light up URcap. In this case, the URcap can be used to turn on a digital output on the robot for a given number of seconds before the output is turned back off. Recall that a URcap consists of a number of different Java classes. First, Polyscope calls the activator, and the activator registers the various services the URcap provides to Polyscope. The service will create the user interface, or view, and the contribution when these are needed. When designing the view, the first thing we need to do is consider the layout. We know that the user needs two different controls, respectively a control for selecting which output to light up and a control for selecting the duration of the light up. When selecting the output, for example, there are a number of different objects we can use. We could use checkboxes, we could use radio buttons, or we could use a drop-down for selecting the output. When selecting the duration of the light up, we could, for instance, either use a free text field or a slider for selecting the duration. In our case, we decide to use a drop-down for selecting which output to light up and use a horizontal slider to select the duration of the light up. It's generally recommended to do a mock-up of this style when you're developing your view in order to help you along the way and ensure that you're going in the right direction. Looking at our view class, we first want to finish our constructor. In our constructor we get the view API provider, and we want to store this locally so we can use it later throughout our class. To do that, we create a private final object, which is the view API provider. We can call this API provider. Now we want to assign the API provider provided as an argument to this API provider in blue. We do this in our constructor by saying this API provider is equal to the API provider provided locally. By using this, we are referencing the instance variable in our class, and without using this we get the local instance of the variable named API provider inside this constructor or method. When our UI needs to be built, Polyscope will call the build UI method. The build UI method provides two arguments, respectively a JPanel and a contribution provider. The JPanel is the panel that we will have inside Polyscope, and which is the panel that we need to add all our user interface components to. The contribution provider provides us access to the active instance of the contribution inside of Polyscope, and we can use this to, for instance, store our settings when the user is interacting with the user interface. The first thing we want to do inside our build UI method is to add a layout manager. Layout managers are used to arrange components with respect to each other inside a container. In this case, the container is the JPanel. To add a layout manager, we'll say panel.setLayout. The setLayout requires a layout manager object, so we'll create a new box layout. Box layout requires two arguments, respectively the panel that it applies to, in this case this is the panel, and secondly, how the objects within the box layout should be arranged. In our case, we want to arrange our components along the y-axis within our panel. So now we add a layout manager that will arrange all the components that we add down along the y-axis within our user interface. Now that we added the layout manager, all the components that we add to our JPanel will be arranged along the y-axis or vertical axis of our page. So now we can consider what kind of building blocks do we actually need in our user interface according to the mock-up that we made. We can argue that we need a box with a J label which first instructs the user to select which output to light up. Following that, we need another box where we have a J label that says digital output and a combo box for selecting the particular output. Then we might need to have a spacer to create some air inside our panel between the selection of output and duration. And then we need another box with a J label for selecting the duration of the light up for that description. The final thing we need is a box where we have a horizontal J slider and next to that a J label that shows the active value of our J slider. So now we want to add these various building blocks to our user interface. The first component that we need is the description for our user interface. We'll first create a private box method that we can call create description. That takes a string argument, which is the description. A box is really a J panel that has an already added box layout on top. And first we want to create a box object that we can call box, and we'll make this a horizontal box. Within this box we want to left align our components. So we'll say box.set alignment on the x-axis and use component left alignment to align our content. Inside this box we want to add a J label, which we can call label, and this will be a new J label that takes the string argument description. We'll now take this J label and add it to our box by saying box add and then add our label. Finally, we want to return the box that we have just created. Now we have a method that creates a box with a J label on top that we can decide. We want to add this to our J panel in build UI by saying panel.add and then create description. And here we'll add the description text, which is select which output to light up. So now this box with a J label will be added to our user interface. After creating the description, we now want to create the combo box or drop down that the user can use to select the output. First, we want to create an instance variable, a private JCombo box of the type integer. We'll call this IO combo box and use it to create a new JCombo box. The reason we're creating the variable out here is so that we can both use it when we are creating the component inside the user interface, but also so the contribution can later access the combo box and, for instance, set up the selected item or the list of items that should be present inside the combo box. Now we'll create a private method that returns a box. We can call this create IO combo box. As an argument here, we want to provide the IO combo box that should be used. In this case, we'll say a final JCombo box of the type integer. We can call this combo. Inside our create IO combo box method, like we did with our description, we want to create a new box. We can call this box. And this should be a horizontal box. Also, we want to set the alignment to left as well. The first thing we need inside our horizontal box is a JLabel that says digital out. So we'll create a label where the string will be digital out, and then on our box we want to add this label. Following the label, we now want to add as well our combo box object. And finally, we want to return the box when this method is called. Now we've designed our method for creating our combo box, and we want to add this as well to the panel in Build UI. So we'll say panel add, and then create IO combo box, providing the IO combo box argument to the method. So now this will also be added following our description inside our user interface. The combo box will by default take up all the available space in the parent container. In this case, well, the combo box takes all the available space in the entire JPanel, which is probably a bit too large. Therefore, we want to do a bit of size management on our combo box. To do this, we'll take our combo object and say set preferred size. Set preferred size requires a dimension object, so we'll create a new dimension. And let's say set a width to 104 pixels by 30 pixels of height. So this will now be the preferred size of the object. But we also want to restrict our combo box from growing larger than this. So we also say combo box.set maximum size. And here use the preferred size that we already defined by saying combo.get preferred size. Now by adding this size management to our combo box, we'll have a much more reasonable size that fits our user interface. Now our combo box is looking as we want it to. The next thing we want to do is that we want to be able to get notified whenever the user changes anything in the combo box. To do that, we'll add an item listener to our combo box that will get executed every time the user changes anything. So we'll say combo add item listener. Here we'll create a new item listener, and the item listener has one overridden method which is called item state change. Right now we haven't developed our contribution, and hence we cannot set the value in our contribution just yet. We'll get back to this later. But what we can do is that we can ensure that the item event that we get is actually the one that we want to react on. To do so, we'll say if the item event E get state change is equal to the item event type called selected. There are a number of different events, and we only want to react in the case that the user selected something here. So now we will have the possibility for this event to fire every time the user acts with the combo box. We also want to allow the contribution to set up our combo box, for instance defining the list of items or setting the selected items. This is the domain logic for the contribution. To do this, we'll create a public void method that we can call setIO combo box items, where we'll take an integer array called items that we want to add to our combo box. First, we want to make sure that the IO combo box is indeed empty. So we'll say IO combo box remove all items, followed by IO combo box, and then set model. In our combo box model, we want to create a new default combo box model where we provide the items that has been given as an argument to this method, and hence setting up the contents of our combo box. So now we have the items that are present. We also want to be able to set the actually selected item from the contribution. To do this, we'll do another public void method called setIO combo box selection. Well, once again we'll take an integer, which is the currently selected item. Here we'll say IO combo box.set selected item, which in this case is the item provided. So now our view and contribution has the possibility to communicate, hence for the contribution to set up the items in the combo box, and also for the view whenever the combo box is altered to tell the contribution of this change. Before adding our duration selection logic, we first want to create a bit of space inside our UI. To do that, we want to add a method that can add a spacer. First, we'll make a private method that returns a component, call it create spacer. Here we'll take an integer for the height as an argument. In our create spacer, we want to return a rigid area, which we can use box and then create rigid area. Rigid area is basically a blank space that we can use to create spacing within our user interface. Here we need to decide on the dimension. We don't really care about the width, but we want the height to be the specified height in the method. We want to add this spacer to our build UI method by saying panel add and then create spacer. We want to use a height of 20 pixels for now as spacing between our components. Now we want to create our slider for selecting the duration of the light up. As we did with the combo box, we also want to create a private object, private instance variable, which is our JSlider. We'll call this duration slider. This again is so that the contribution can also later set the value of our slider. Now that we've created our duration slider, we now want to create a private method for creating the box where we want our slider to be in. So we'll create a private box returning method called create duration slider. And provide a final instance of the JSlider as an argument and call it slider. For the slider, we also need to provide another argument, respectively the minimum and maximum value of the slider, and we'll do this by making an integer argument for the minimum value and an integer argument for the maximal value of our slider. Inside the method here, we want to start by creating our box and left align our components. Now that we have our slider, we want to set it up to use the minimum and maximum value. We'll say slider dot set minimum and use the minimum argument provided by the method. We'll do the same thing for setting the maximum value. Another thing we want to ensure is that our slider is indeed horizontal. And to do so, we'll say slider dot set orientation and ensure that this slider will be a horizontal slider. Now our slider is generally set up and we want to add it to our box. And finally return the box when this method is called. Now a method here for creating the slider box is ready, and we want to set it up inside our build UI. First though, we want to add a description that says select which output to light up. We'll reuse our create description method to do so. Here we'll say the string is select the duration of the light up. And then we'll add the slider. First by providing the duration slider argument, and then we can set the minimal value to 0 and let's say the maximum value to 10 seconds in this case. So now we both added our description and our slider to the user interface. As with the combo box, the slider also tries to take all the available space in the parent JPanel. So here we also need to do some size management. And we'll do this by going into our create duration slider method and set the preferred and maximum size for our slider. By saying first set preferred size. And this time using a width of 275 pixels by 30 pixels of height. Then also restricting the maximum size to the same value as the preferred size. Now we've size managed our slider. Now we also want to add a JLabel that shows the actual value of the slider. Otherwise it's difficult for the user to see what the value actually is. To do so, we'll add a JLabel object, which we can call value. Make this a new JLabel. Here we want to use integer to string and then convert the slider's actual value into a string for our JLabel. Following the value, we want to add the unit, in this case seconds. Now this is okay, however the value is only updated when we call create duration slider. We want this to happen dynamically every time the slider is changed. To do so, we want to add a change listener to our slider. We'll say add change listener and create a new change listener. In the change listener, the overridden state change event is called every time the value of the slider changes. Hence in here we want to store the value and save it in our JLabel. So we'll say the new value is equal to what we can read from the slider. And then take this new value and set it in our value JLabel. We'll say value set text, and then once again use integer to string conversion. And then add the new value. On top of that, we as well want to add the seconds annotation. Now this event is called every time, and the value will dynamically be updated inside the view. However, we just need to add the value label to the box as well. And look at our results. Now we got our slider up and running, but we also want to be able to set up the value of the slider from our contribution to reflect the settings in the actually selected node. To do this, we'll create another public method, as we did with the IO combo box, where we can set up the value of the slider. So we'll create a public void method that we can call set duration slider. And in here, we'll take our duration slider and say set value, and then set it to the specified value. So now our duration slider is also up and running and can be configured from the contribution. Another thing we can do to our user interface is to add a bit more space between the description labels and the input components, both for the I/O combo box and for the slider. To do this, inside our build UI, we'll say add to our panel, and once again use our create spacer. And for this use, just a mere 5 pixels should be enough to create a bit of air between the description label and the I/O combo box component. Do the same thing between the select duration of the light up description and the duration slider. So we'll say create spacer and add an additional 5 pixels here. And now we want to look at our final view as we have created it. Now we've completed the development of our view, and in doing so we've taken the JPanel that we get from build UI, and here we've added first a description label, then the I/O combo box, followed by another description label and the slider. All of these components are all built using private methods that return a horizontal box that makes all our components nicely aligned inside of our box layout. We've also created 3 call-in methods that the contribution will later be able to use to set up the view to reflect the settings of this node. What we are still missing though is that inside the event listeners, respectively the item listener of the I/O combo box and the change listener of the duration slider, is to provide a functionality where we can here set the value in our contribution. We'll get back to this later when we've also developed the contribution and have the appropriate methods here that can receive these values. Now we have successfully developed our view class. In the next video, we'll start developing our contribution.